Right then, gents. We're going to be looking at high voltage contactors and their role within the high voltage system. So we'll start off by having a look at the basics of electric vehicles and then working up to why we need contactors, what they do, and how they work. So obviously, if we're going to power our vehicle with electricity, the two things we need are obviously going to be a battery and a motor. And between the two, we're going to need some sort of control so the motor doesn't run flat out all the time. So if it's a DC motor, we're going to have a controller, and if it's an AC motor, we're going to have an inverter. So the inverter is going to provide the AC motor with a moving AC waveform. The rotor then follows that, and that's what drives the car up the road. And virtually all modern mass-produced electric vehicles will use the AC motor. Now, what we're going to have in our inverter, our controller, is we're going to have a big capacitor. And the reason we have that is quite normal to have a capacitor on an incoming power supply to any electronic unit. And because this is a very high power unit, we have a very big capacitor. So this is starting to form the high voltage system as we have it in the car. Inside the battery, we've got lots of cells all joined together in series. And then in our inverter, we've got our great big capacitor. Now, that doesn't give us any protection at all, so what we're going to add is a fuse, so that if we get some sort of short circuit or overcurrent situation, we'll add a fuse. This is what that looks like. So this particular one's out of Renault Zoe. It lives inside the battery pack. It's rated to 275 amps. So it's designed to provide 275 amps continuous power through that fuse, and it's got an instantaneous braking rating of 6,000 amps. So if that breaks instantaneously, you've got a fair bit of power going through it. Okay, now what we can do is it's desirable to have some way to disconnect the high voltage system because we might want to repair the car, and obviously we don't want to repair it while it's live. So what we can actually do is we can build that fuse into a removable part of the battery pack. We can take that out, and that means we can make the car safe to work on. So that'll be built into a little service plug. It'll have a nice brightly coloured orange handle on it. We can pull that out, and we're physically removing a link inside the battery, and the high voltage fuse, or one of the high voltage fuses, is generally located within that plug as well, so it's easily replaceable. Okay, now the problem with that is that doesn't give us the vehicle any way of disconnecting the high voltage system. So what we need, and this is where we see our contactor, we have a little relay so that the car can turn off the high voltage system. So for example, we're going to want to turn off the high voltage system if the car has a crash. And in reality, we actually have the car high voltage system off all the time. We have the 12 volt system connected so that our central locking and everything else can work. But we only connect the high voltage battery when we need it. So if we're charging it, if we're driving, that's when we turn it on. The rest of the time, that high voltage system is going to be off. So we have this contactor here, and this is what it looks like. So the contactor is just a relay. Some manufacturers call them system main relays, some call them contactors, some call them high voltage relays. They're all the same thing, and it is just a relay by another name. The only difference is that we've got 12 volts turning the relay on and off on the coil side, and on the contact side of the relay, we've got the full high voltage system voltage. So the contactor performs two functions, which are both fairly basic. When the contactor is on, it needs to pass the full current for driving the vehicle through the contactor, because obviously everything has to go through that. And when the contactor is off, it obviously has to provide a safe isolation barrier between the part of the battery that's always on and the rest of the car that we want to be off when the car is safe. And the sort of figures we're talking about, if we think about a high performance electric vehicle like a Porsche Taycan, we're talking about 800 volts and 800 amps. So there's quite a serious amount of power that all has to go through this device to get it in and out of the battery. Okay, now there's a problem with our high voltage system as we have it like this. And that is when we come to start the high voltage system, we've got, for example, 350 volts in the battery. We've got 0 volts in our capacitor. And because our capacitor, although it's a very small storage of electricity, it's a very rapid storage of electricity. So when we first turn that contactor on, we're going to have 350 volts on one side, 0 on the other, and we're going to get a huge inrush of current that's going to want to charge up that capacitor. Now, the problem with that is on our little contactor that we just saw, just as that contactor starts to close, the contacts inside it start to close, that huge current is going to want to jump in across those contacts. And what actually happens is it starts to arc just before they close, and that arcing at such a high current will actually weld the contactor so it's stuck on. So the first time we started the car, our contactor is going to be no use. We now can't turn it off again, because as soon as we turn it on, the current is going to weld it together, and then there's no point having the contactor. So, to get around this problem, what we do is we add another contactor that initially starts the high voltage system via a resistor. So the resistor will limit the flow of current, so we don't have this huge rush of current through that contactor that's going to weld the contact shut. So what we do in this situation is we can see the left contactor there goes via the resistor, so we'll turn that one on first, and we'll still get the current coming through charging our capacitor, but it's going to be much more slow because it has to go through that resistor, so it limits that current flow, and that way it protects our contactor. Then once our voltage in the inverter starts to come up to a similar level to the battery, typically about 95% of the battery voltage or something like that, it will then turn the main contactor on, and then of course our high voltage system is fully on, and it will then turn off the pre-charge. That pre-charge is just used very periodically when we first start the car, and it's purely there so that we don't have that huge current going through that contactor just as it closes. So this is what it looks like. So this is a pre-charged resistor, and it's just typically a wire-wound resistor, normally anywhere from about 10 to about 80 ohms, and it's purely there to limit that inrush of current when we first turn it on. You'll also see that our pre-charge contactor is a lot smaller. It looks much more like an ordinary relay, and that's because, of course, this only operates via that current-limiting resistor, so there's no need for it to be a great big contactor. It only has that small amount of current for a small amount of time when we first start the car, so it can be a relatively small relay. And inside the vehicle, so this is a Renault Zoe battery pack. This is how it's all laid out. So this red terminal here is our permanent live in the battery, if you like. That's got 350 volts on it all the time. And you can see the various protection devices. We've got a nice 275 amp fuse. And then this is our pre-charge relay. This is our pre-charge resistor. And that's our main relay or our main contactor. And that all lets power come out. And then obviously that connects the rest of the battery up to the rest of the car. So the contactors will always be located inside the battery pack, because of course we want to be able to turn the battery pack on and off. If they were somewhere else, then the battery pack would still be live when we went to unplug that bit. So they're always located within the battery pack. Okay, now what we often have in reality is we also have another contactor on the negative side as well. And this provides us with some backup. So if a contactor does stick on, then we've got another means of turning it off. And it means that battery can be fully isolated from the vehicle. So if it has got some sort of safety concern or something, we can disconnect both terminals of that high voltage battery and make it completely safe. You'll see we don't have a pre-charge resistor on the negative side, and that's because we only need one current limiting device in this circuit. So the way this vehicle would start up is we'd turn this one on first of all, and there'd be no huge rush of current through that because we haven't got a circuit. So there'd be no current whatsoever when that first comes on. So once this is on, if we then turn one of these on, we'll then have a circuit. So we then turn on the pre-charge. That then starts to bring up the high voltage in the inverter. And then once that's come up to an acceptable level, like I say, it's normally about 95% of whatever the battery voltage is, we can then turn on the main contactor and we'll turn off the pre-charge, and we're then up and running with our full high voltage ready to drive. So the way to tell if a vehicle has contactors on both terminals or just one is to look at that safety isolator. So if the safety isolator has 4 pins, that is high voltage in, high voltage out, negative, high voltage in, high voltage out, positive, and that means you only have the main relay and the pre-charge relay. You don't have the relay on the other terminal. And the reason it's like this is because we still have a method for disconnecting, in this case the negative, because the contactors can only disconnect the positive, so we can disconnect the negative by removing this plug. If it only has 2 pins on this isolator, or it doesn't have an isolator at all, which we'll come to a little bit later, then you know it's got contactors on both sides. Okay, so this is the sort of voltage and current we have as the high voltage system starting. So we've got the voltage in blue and we've got the current in red. Now what you'll see at the moment that pre-charge resistor first cuts in, you'll see that we've got a real big spike in current, which is the red one. And the reason for that is we've got a really big difference in voltage. So we've got 350 volts on this side and we've got 0 volts on this side. So we've got such an imbalance that we're going to get a huge current rushing between them, and that's why we get this great big spike on the red down the bottom here. And obviously we've got the pre-charge resistor in there, so it's actually limited. You can see in this case it's, I don't know, about 12 amps or something like that, and that's the pre-charge resistor stopping that from getting to a ridiculous current. What you'll then see is the blue, the voltage starts coming up because obviously we've got a circuit now, it's all connected. So as the voltage starts coming up, the voltage difference between the battery and the inverter becomes less. So if we've got 350 volts in the battery, by the time we get to 200 volts at the inverter, our difference is now only 150 volts, and that's why you can see the current starts to tail off. So what we get is our voltage rises like this, our current then drops off like this, and then eventually we end up in a situation where the voltage is the same in the battery at the inverter, and then both of them level off. And we just have a tiny little trickle of current on our red, and our voltage is the same as the battery voltage. This is another one from a different vehicle. Now this is a fully functional vehicle where we have the main contactor working as well. So again, you can see that spike in current as the contactor cuts in, the voltage comes up, and you'll then see we've got a second spike. Now this is because this is from a working vehicle, and that's because when we cut the main contactor in, we're now bypassing our pre-charge resistor, which was limiting the current. So when you take the current limiter out, you get another little burst of current, and then of course once the voltage is the same on both sides, then the current tails off. It doesn't go down to 0 because of course our high voltage system is now on and working, and we're going to be charging the 12 volt battery and having everything else going on. You can see we've got a bit of noise where things are starting to go on as well. But that's how we start the high voltage system. Okay, now you do get cars where they don't have that isolator. So that big fuse that we talked about that you can pull out the middle of the battery pack to isolate it, not all cars have that. Some cars have one of these silly little things. It's normally located under the bonnet somewhere, and you'll typically find these on most German brands. So you'll see them on VW, Mercedes, BMW, other VAG, some of the Porsches, and we're starting to see them on Peugeot, Citroën as well, some of the later ones. And the funny thing about this is not actually connected to the high voltage system. So when the manufacturer designs the car, they say, oh, well, we don't want our guys in our workshops to be touching the high voltage system, so what we'll do is we'll give them a nice low voltage thing in order to disconnect it. The problem is, if it's not part of the high voltage system, then how does it turn the high voltage off? And the question is, the answer is, this takes the 12 volt supply off the contactors then all spring open, and then the high voltage system is then perfectly safe, as long as they're not stuck on. So, how does it work? What is it actually connected to? So if we look at the wiring diagram, we've got 4 wires on that little plug, and one of them is part of what we call the high voltage interlock circuit. So the high voltage interlock circuit goes through the various high voltage connections in the car, so that if you pull one of them off, the car knows that one of those connections isn't connected, and it then turns off the high voltage system. And that's something we have on all electric and hybrid vehicles, so that you can't pull a connector off while it's running and stick your fingers in the end. As soon as you start to break that connection of that connector, the car knows, because it breaks the interlock circuit, and then it will then turn off the high voltage system. Okay, so when we pull our plug out, it breaks the interlock system, so the car thinks, oh, hang on a minute, someone's unplugged something, I better turn it all off. The other thing it does, just in case these wires are shorted together or got some other little nasty issue that might try and electrocute us, is we've actually got a power supply for the battery control unit here. So in this case, this is terminal 30C. Now, terminal 30C is something you get on German electric vehicles, and terminal 30, as we know, is the 12 volt permanent live, and terminal 30C is a live that's there all the time unless the car has been crashed. So that'll be there when the car's switched off, and the only time that terminal 30C gets switched off is when the car's in an accident. There's normally a little firing pin on the side of the battery terminal that blows a little thing off the terminal, and that gets rid of your terminal 30C, and that way it disconnects the high voltage system. So when we pull that little plug out, we get rid of terminal 30C, which is going to turn the battery control unit off. We're also going to open up our high voltage interlock system, which is going to tell the car to turn off the high voltage system. So we've got sort of two systems, just in case one's shorted together or something like that, that will, in theory, turn off our high voltage system because it takes the 12-volt supply away from those contactors. Okay, so when we have this system, this is what our wiring diagram looks like. So you can see we've got a contactor on both sides, main contactor on both sides, and we've also got the pre-charge contactor. Now you can actually have the pre-charge contactor on the negative side, because as long as it's somewhere in the circuit, it doesn't matter where it is. So some vehicles will have that on the negative side, but you'll always have a pre-charge on one side or the other. The only problem is, with taking the power away from the contactors, is when the contactors are stuck on. And this is why it's quite important, especially for vehicles that don't have that physical link in the battery that you're pulling out. If it's got one of those pathetic little stupid green things under the bonnet, then it's really important to make sure that you do check that your high voltage has disappeared in order to make sure that that vehicle is safe. Now, this is an interesting thing, a welded contactor, because how does the car know that it's stuck? Because if we go back to our picture of our contactors, we've got them on the positive and the negative side, and you think it's easy to tell if both of our contactors are stuck on, because what we'll do is we'll turn them off, and then if we've still got high voltage over here, then obviously the contactors are stuck on. But let's say we first turn off the positive one. If we turn off the positive contactor, our voltage in our inverter is going to start coming down. How are we ever going to know, when we turn this off, the circuit's already broken, how are we ever going to know whether the negative contactor is stuck on? No, I don't know either. No. The way we do this is we actually have a programmed sequence that it turns the contactors off. So what it does is it will say, first, I'm going to turn off the positive. And what I'm going to do is I'm now going to expect this voltage to drop in the inverter because we've opened up the circuit. And I'm now going to open up the negative. And that voltage is still going to drop because obviously we've already opened up the circuit. But the clever bit is I'm now going to turn the first one back on. And what happens if the first one, when we turn that first one back on, if the voltage goes back up, we think, hang on a minute, that one obviously didn't go off. And you can see that on the live data. So if you get something like a Nissan, for example, this contactor test is done when you turn the car off. So the car's on, it's driving, it's all absolutely fine. You press the off button, it will then run through its little sequence of contactors, and it will say, hang on a minute, and you'll see it in live data. You'll see that voltage start to come down, and then you'll see it spike back up again, because the other one didn't come off when it was meant to, and the car will say, oh, hang on a minute, we've got a contactor fault here. It then won't let you start the car again. The reason it won't let you start the car is because potentially we'll stick the other contactor on, and then we're going to end up with a car that we can't get rid of the high voltage. So for safety reasons, get a problem with one contactor, then it's no more start. Okay, now the AA have dumped that car outside the workshop. How do we get it in the workshop? Well, the car can actually only do this test when you turn it off. So if you clear the code, the car doesn't actually know that the problem's still there. So if you clear the code, you'll find that the car now thinks there's nothing wrong with it because it's thinking, well, I've got 0 volts this side, I've got high voltage in the battery, everything looks okay, I'll start the car up. So it'll start the car up, it'll turn all the contactors on in the right sequence, car will start up, no fault codes, you can drive it about, no problem whatsoever. And then as soon as you turn the car back off again, it's going to run through that same test and it will say, hang on a minute, you've got a contactor fault here. So that's how we get our contactor check. Now, another way of turning off our contactors, because all the contactors are powered by the 12-volt system, aren't they? So I think another way of isolating our high voltage system, if perhaps we don't have the official procedure from the manufacturer, we'll just take the 12-volt battery off. Because if we take the 12-volt battery off, you can't turn the contactors on, can it? If that's where they come from. So what we can do, and when I've done this presentation before, I've actually had my car on the stage, so I've taken both terminals off the 12-volt battery, and then I'll get in the car, and I'll drive it around the stage. Now, how does that work? Because we disconnected our 12-volt battery. So how do we get power? Yeah. it's not a 12-volt battery that powers the car, is it? The 12-volt battery stores the power when the car's off, but whenever the car's awake, the car's powered like a traditional car will be powered by the alternator. And in the old days, you probably wouldn't want to do it with modern electronics, but in the old days, you could disconnect the battery while it was running to make sure your charging system was okay. Exactly the same with this. When the car's on, it's our DC-DC converter that's powering everything. Take the 12-volt battery off. Don't matter, it's still got 14 volts everywhere, isn't it? So, yeah. So don't use that. Don't rely on that system to make sure the high voltage system's safe. And if you do take the 12-volt battery off, and then you look inside and you see all the dashes all still lit up and everything, that's because the high voltage system's still on and the DC-DC converter's powering everything. Okay. So some manufacturers, they actually recommend, and they don't normally tell you why, but they'll actually say if you want to disconnect the 12-volt battery, first you need to disconnect the high voltage. And you think, oh, do I? Why do I need to do that? But it's to prevent this from happening, because if you've turned off the high voltage, you know that when you disconnect the 12-volt battery, then it is properly off. Okay, so when we want to turn off the high voltage system, we can obviously turn off our contactors, and then our voltage will sit in our capacitor, because this is an electrical storage device, so it's still going to have voltage sitting in it. So what we actually have in the inverter is we have two circuits. One is called the passive discharge circuit, and that's just a resistor that goes across that all the time, and it just means that when we take the power away, we've got something there, and it doesn't actually do anything. All it does is it uses a bit of power, and all it does is it will drain that high voltage out of that capacitor, because we want the system to be off, so we don't want that voltage to sit in there and wait for us to put our fingers in it or anything else. There's also normally another resistor, which is called the active discharge circuit, and that is exactly the same principle, but it can just switch it in as and when needed. So let's say, for example, you have a crash. Let's say, for example, you've got a car in the workshop and you say, oh, this would be a laugh, I'll put one of these high voltage connections off while it's running. The car will say, oh, someone's opened the interlock circuit. That's when it would use that active discharge circuit, so it can bring in another resistor that's got a much lower resistance. It's a much higher power resistor, and that will get rid of that voltage virtually instantaneously to make sure that the car's safe. But we always have the passive discharge circuit, so that if there's any fault or anything, we've always got a little bit of a drain through there that will always get rid of it. Okay, now sometimes we can have a fault where the contactors don't switch on properly, and of course this means we can't start or charge the car. And this is quite interesting, because sometimes EVs are quite good at diagnosing what the problem is, and sometimes they're not. And this is one of those cases where they're not. So what's going to happen is the car will say, right, I want to start the high voltage system, so I'm going to turn on our negative contactor, not expecting any voltage yet, because obviously there's no circuit. So we'll turn on the negative contactor first. We're now going to turn on our pre-charge contactor, and as we know, we should now see our high voltage start to rise at our inverter end. Well, guess what? It doesn't meet the target. We don't get to our 95%. So the car says, oh, I'm going to set a fault code. We've got a problem here. And the fault code will say, I couldn't start the high voltage system, but I don't really know why. I tried turning the contactors on, and I thought something was going to happen, and it didn't. It's normally worded a little bit differently to that. But, so, possible causes. If we've got a short in our high voltage system, what will happen is when we turn on our pre-charge resistor, our entire voltage will be dropped across that resistor. We will have hardly any voltage here, and the car will say, oh, I can't start the high voltage system. And if we look at live data, we'll see we've got a very low voltage reading at our inverter end. Okay, so let's look at another type of fault. Let's say we haven't got a short in the high voltage system, but we've got an open circuit in our pre-charge resistor. So, different fault, but the way the car sees it is exactly the same. It'll say, well, I'm turning on the relay and I'm not seeing any voltage. And that's all I know. I can't see anything else. Okay, what if we have an open circuit in our negative contactor? Same fault again. Still doesn't know what the problem is. It will say, well, hang on, I've turned everything on, but I don't know, it might be a short, might be an open circuit somewhere. It's definitely something wrong, but I don't know what it is. And this is where we need to use a bit of ingenuity, and we need to actually come up with some procedures to get to the bottom of these issues. The thing we find with electric vehicles is we get a lot of electric vehicles that are half under warranty. So if you get a typical electric vehicle, most of them, they have a sort of 3-year warranty, but they'll put an 8-year warranty on the battery. Now that 8-year warranty in the battery will cover everything in the battery, and of course that includes our contactors. So when you get this sort of problem, you say, well, if it's in the battery, then you'd be better off going to the main dealer and they'll fix it for nothing because it's under its 8-year battery warranty, because the car's only 5 years old. But actually, if the fault's not in the battery, then it's not under warranty, and you'd be better off coming here because the main dealers can charge lots of money and they might just throw parts at it. No offence to any main dealers here. What we're going to do is we need some good tests in order to say, is the fault in the battery or is the fault in the car? It doesn't matter at this exact moment what exactly is causing the fault, but if we can just say whether it's one side or the other, then we know whether we're going to carry on with that diagnosis or whether we're going to send that car to the dealership. And obviously we have some interesting tests in order to work out what the issue is, because the car won't know. Okay. Now, we actually have one more set of contactors in the car, and that is for DC charging. So what we have in the vehicle is we have a charger built into the car. And the reason we build the charger into the car is because then we can plug it into an AC power supply that we can get from our grandmother's house or at the side of the road or anywhere, get a bit of AC out of the wall, plug it into the car, and we can charge the battery up. So we build the charger into the car. Now the downside of this is the charger in the car we have to carry around everywhere with us, so it ain't very big. And sometimes we want to charge the battery up really fast. So what we do is we get a really, really big charger that we're not going to carry around in the car, and what we'll do is we'll leave it at the motorway services, and then we'll plug it into the car. And of course, what we want is the charger is going to be outside the car, so we now need to connect to the DC part of the car. Now, having live high voltage on the charging socket is sort of frowned upon. So what the manufacturers do is they give us another couple of contactors so that we can disconnect the charging socket. So when we're driving the vehicle, we'll have all of this part of it live, because obviously we need that on to charge it, but we'll have these two off because, of course, we don't want to have live high voltage on our charging socket. Now, when we plug into a charging point, it will do some communication between the vehicle and the charging point. Depending on the charging standard used, that'll be either CAN bus or TCP, but one way or the other, it's going to communicate between the car and the charging point, and when it's happy with everything, it will turn these two on, and then, of course, the charging point can then put DC power into the car, and we can charge it up really quickly. So if we're hanging around at the services, obviously we only want to wait about half an hour for it to charge up. We don't want to sit there for 8 hours. So we'll plug into DC, have these on, straight into the battery, bam, really fast. Okay. So obviously if they stick off, we ain't going to have any DC charging. So we'll still be able to charge it at home, because that doesn't use this system. We've got our charger that's built into the car. But what happens if they stick on? Ooh. Well, is it going to know if they're stuck on? And the reason is it will actually know if one of those is stuck on, because that same sequence we talked about earlier, where it can turn one off and then it will turn the other one off and then it will turn the first one back on, it will do the same thing. And the communication between the car and the charging point will share what voltage it's seeing on that line, so that it can check those DC charging contactors have correctly come off, so that we know there's going to be no high voltage on that socket. Now, if they do stick on, what's going to be the symptom? The symptom, if these two contactors stick on, is the car won't start. And you think, wow, why won't it start? Surely it can still do all this and everything. But it's a deliberate safety feature that's built into the car, because if you start a high voltage system and your contactors here are stuck on, we're then going to end up with live high voltage on that socket that someone might stick their fingers in or something like that. So for that reason, it's a deliberate safety feature that's built in, so that if those contactors stick on, can't start the car. Okay. Well, hopefully you found that quite useful insight into contactors. If you're interested in knowing anything more about what we do at HEVRA, then you can come and find us at our stand over there. But other than that, that's the end of the presentation. I hope you enjoyed it.